24, exercise 17. So the first part of this is we need to combine all of these capacitors into one equivalent capacitor, figure out all the details about that equivalent capacitor, and then split it back apart into the individual pieces and figure everything out one step at a time. So we've got 4 of these capacitors. The ones that we're going to want to combine first are C1 and C2. Because they're on one isolated branch, they're in parallel or in series with each other. So those are the ones we want to combine first. So we'll redraw this circuit with those two put together. So this one was C4, C3, and this one up at the top will now be the combination of C1 and C2. Now since they were in series, they add inversely 4 microfarads each, so that's 2 over 4. If we invert everything, that means our equivalent capacitance for those two is 2 microfarads. So now we want to add that with C3. So C3 is 4 microfarads, as is C4. So this is the circuit we're going to end up with once we combine those two. Now combining capacitors in parallel is easy. The capacitance just adds together. So 2 and 4 is 6. The lower one is still 4. Then as a final step, we add those last two. Now they're in series, so we need 1 over 6 plus 1 over 4 is 1 over the equivalent capacitance. So the common denominator there is going to be 12. So we end up with an overall equivalent capacitance of 2.4 microfarads. So I can represent that entire circuit by this one equivalent capacitor of 2.4 microfarads. Now we know there's a potential difference here of 28 volts. That means this also has to have 28 volts. That's the point of reducing it to one equivalent capacitor, is it'll have the same capacitance as the source. And then from our definition of capacitance, we can figure out charge, which in that case will be 2.4 times 28, which is 67.2 microcoulombs. So this is our equivalent capacitor with its voltage and charge, and what we're going to do in the next video is work this backward, go back through this process until we have them all individually with the charge and voltage on each one.